Finally, we come to the last part of fractional distillation of crude oil. Again, I would like to have a recap of what we have discussed in the last video. In the last video, we try to compare different properties of the fractions. We compare the color, we compare the viscosity, and also ease of evaporation. And from other videos, we compare the flammability and the amount of black smoke produced when burning. So we have this flow chart. We have filled in the chart to indicate the trend of the change of the properties of different oil fractions. And in the last video, in the last part, I give you 4 questions to think about. Which fraction is the most and the least suitable to be used as fuel and also as lubricant? So from the YouTube, from the comment box, I only see one student actually leave his answer there. So what's the answer here? Which one is the most suitable to be used as fuel? So it will be fraction number 1. The reason is it is easiest to burn. It has the highest flammability and it burns with the least sooty flame. That means it will produce the least amount of air pollutants. And in contrast, fraction 4 will be the least suitable to be used as fuel as it's most difficult to burn, it has the lowest flammability, and also it burns with the sootiest flame. So that means it pollutes the air heavily. However, for fraction number 4, it has some special uses such as lubricant. So which one is the most suitable to use as lubricant? In contrast, I would say fraction number 4, it will be the most suitable. The reason is it is the most viscous. That means it can stick the different parts of the machine, such as the gears. So it is most viscous. It can help reducing friction between the mechanical parts. And also, as it is the least flammable, it is the most difficult to evaporate. So that means fraction number 4 can stay between the mechanical parts for a longer time, and it as is the least flammable, it will not catch fire. So it is safe to use when it being used as lubricant. In contrast, for fraction number 1, it is the least suitable to be used as lubricant as it's the least viscous and it's the most flammable. Imagine you're using the fraction to try to reduce friction. The friction may produce heat. You learned this in Form 2 already. So if you use the most flammable one, it will be very terrible as it will catch fire. And also, it is easiest to evaporate. That means it cannot leave on the mechanical parts for a long time. It's not suitable. So that ends for the last video's last 4 questions. Now for this video, our focus is how to make fractional distillation possible in industry. Now this is the setup for the fractional distillation to be conducted in the laboratory. If you still remember, we have a test tube, I should say we have a boiling tube. We have the heating source such as the Bunsen burner. We need to replace the test tube one by one. However, in the industry, how can we handle it if we have a large amount of crude oil? You can't have a giant test tube, giant Bunsen burner, and giant transportation for those test tubes. How can we do it in an automatic way and also in a large scale? So actually, in the industry, we'll make use of another setup. The setup will look like this. This is the fractionating tower in the industry of oil refinery. So each tower it is having a several meters tall, I should say several 10 meters tall, 幾層樓咁高嘅。And the inner structure is a little bit complicated, so I will introduce you by the following simple diagram. So in most textbooks, the fractionating tower will look like this. The crude oil will be fed in this tube. So this tube will have the input of the crude oil. And this part actually is a furnace, 一個火爐咁樣嘅。 it will heat up the crude oil inside to about 400 degrees Celsius. It depends on the type of fractionating tower being used。隻唔同，唔同國家都有機會唔同嘅。咁主流嘅通常都係400度，400 degrees Celsius。And because the furnace is located here in the main entrance for inputting crude oil, so the position of the tower close to the furnace, of course, it will be hotter. For the position that is further away from the furnace, definitely it will be cooler. So that for the fractioning tower, the lower part will be the hotter region, and the top part will be the cooler region. Now I'm going to add some temperature here for referencing. 大概嘅啫，作出嚟嘅啫。So these are the temperature at different levels of the fractionating tower. You can see the temperature decrease from 400 to 350, 250, and so on to 40 degrees Celsius. So of course, this one is still a little bit warmer than your room. 40度應該仲熱過你間房嘅，夏天就算夏天都係。Alright, and the second thing, for each tower, this part you think it a little bit strange. Now this one is a little bit complicated. You may learn this if you study engineering in the university. 你大學讀工程，特別係化工嘅話，可能會知道呢個嘢。呢個好似蘑菇樣咁樣嘅。This one actually called is a bubble cap。個樣咧就真係有啲難理解嘅，因為我冇個實物俾你，你當係一個浴室嗰個去水位吸住一個唔係好實嘅蓋咁樣啦。A lid that is loosely capped for the bottom part of the sink. So the diagram will look like this here. So the cap will not let any liquid to overflow, but to allow any vapor to pass through the liquid. And for Form 3 level, you just need to realize that the presence of these bubble cap, they can allow the separation of this tower into different layers. So we have different layers of the fractionating tower. So this one is very important actually. Now I'm going to move on the simplified example. Now you know that for crude oil there are hundreds of hydrocarbons and 100樣嘅 hydrocarbon. I just list out around 10 of them. So all of the hydrocarbons they are filled in this part. They go to the furnace and being heated to 400 degrees Celsius. So most of them, they will turn into gas form as the temperature will be higher than the boiling point of those hydrocarbons. However, for few of them, maybe C30H62. This one is having a boiling point 450 degrees Celsius. So it still exists as liquid. Now for those hydrocarbons that exist as gas, such as these hydrocarbons, they will go in and they vaporize and it goes up, then they go up eventually. I'll talk about this later on. Now I move to the first example, this one, C30H62. So this one, because the boiling point is 450 degrees Celsius, if we heat in the furnace 400 degrees Celsius, it still exists as liquid. So if you put this hydrocarbon inside, it will just flow downwards and being collected. 好似 liquid 向下流，佢一定會向下流。So it's being collected. Nothing special here. So this part, for any hydrocarbons with boiling point higher than 400 degrees Celsius, as they still exist as liquid, they will flow downwards and being collected at the bottom part of the fractionating tower. Next one, I'm going to move to the next extreme case, C4H10. How about C4H10? Actually, it is having a very low boiling point, -1 degree Celsius. If you do nothing, just leave it at room temperature, it still exists as gas. So this one, C4H10, when it is being put inside the fractionating tower, it will just goes up, and it will just go up, and nothing can stop it. And the top part of fractionating tower is still 40 degrees Celsius. It still exists as gas. So it goes to the top part and being collected at the top part of the tower. So now these two extreme points, these two extreme positions, they collect those with very high boiling point or very low boiling point to separate two groups of hydrocarbons. Then what about the others here? What about the others here? Now pick the next one, C20H42. So it has a boiling point of 343 degrees Celsius. So if we heat this up in the furnace, it still exists as gas. It will not flow downwards as it is not existing as a liquid. As it's in gas form, it will goes up and it will pass through the first layer, hit the bubble cap, and then it goes to the past the first layer. This one still exists as gas as the temperature at this layer is 350 degrees Celsius. 呢個水平線呢一層仲係350度。The temperature is still higher than the boiling point of this hydrocarbon. So this hydrocarbon will eventually goes up. However, when it goes up, eventually it will reach one position that is the temperature same as the boiling point or condensation point of this hydrocarbon. Now we see, as I mentioned, the tower, the lower part is when because it's closer to the furnace, it is hotter, warmer, having a high temperature. For the upper part, because it's further away from the furnace, it is cooler. So imagine if this layer is 350 degrees Celsius. This layer is cooler, is 250 degrees Celsius. There must be one position in between it is 343 degrees Celsius. Now, of course, I know that it's not in scale， 應該唔會畫到咁高，不過方便講解，我特登畫呢條線喺度。There must be some position in between this layer, having this temperature in between 250 and 350 degrees Celsius。一定某個位置呢兩個溫度中間，我當343度。So when this hydrocarbon reaches this position, it reaches its boiling point. Then also we may call this, it reaches the condensation point. So what happened? It may condense to the liquid. So if it condenses to liquid form, 佢變做 liquid， 佢應該會向下滴嘅。It may drop downwards. However, when drop downwards, the temperature may be higher than 340 degrees Celsius. 呢個位置343度啫，佢變做 liquid 向下滴，喂，下邊可能344度嘅咯喎。Maybe it's 344 degrees Celsius and will vaporize again. So for this hydrocarbon, at most it can stay here. 永遠穿破唔到343度呢個關口 as it reaches the condensation point or boiling point of this hydrocarbon。去到呢個位置，佢一定變翻 liquid， 一定 condense， 咁佢就會 stay in between this layer。佢會一邊 condense 向下滴，再 vaporize 向上，再一邊 condense 向下滴，再 vaporize 向上。So in overall, it will stay in this region. It will stay in this region. How about next one? C13H32. It has a boiling point of 271 degrees Celsius. Again, when it goes to a furnace, it is not exist as the liquid form. 佢仲係 gas 嚟嘅。So it goes up, pass through the first layer. 呢層 layer 冇問題 350 degrees Celsius. It is not being condensed. It still exists as gas. So it will go up. It will go up. However, again, there may be some region. Now, 當然我知道我畫得誇張，呢條頭先條線好似，不過我方便講解我畫出嚟啫。There must be some region in between these two layers is 271 degrees Celsius。向上慢慢會凍，向上慢慢由350度變250度，咁一定某一個位置係278度。So this one, when it reaches a certain point, 271 degrees Celsius, what happened? Again, it may condense and turns to liquid and then stay around this region. So when we put these two cases, both of them they have one similarity. They cannot pass through this level, the level with the temperature exactly equal to their boiling point. Now for both of the cases, they can pass through the first layer because the temperature here, 350 degrees Celsius, is still higher than the boiling point of these two compounds, these two hydrocarbons. However, they cannot pass through this layer. 佢穿唔過呢一層 because this layer is 250 degrees Celsius. They will be condensed at certain point in this layer. 呢度一定兩層之間某一個位置會 condense， 會變做 liquid 向下滴，穿唔過第二層。So they're trapped between these two layers. They're trapped between these two layers. Eventually, they may be collected in this layer. Okay? 好。How about next one? C10H22. Well, this one, when it goes up, it can pass through the first region, first layer. 點樣穿得過啊？ The boiling point is 174 degrees Celsius. Still lower than 350. 呢度唔可以凍到去 condense， 唔可以截住佢。How about the next layer? This time it can pass through the next layer. Why? This layer is 250 degrees Celsius. 佢 condense 未啊？未到 boiling point. It still exists as a gas. 佢仍可以用 gas 嘅姿態穿過呢一層向上添。However, when it reaches certain position, it will be condensed here. Why? The next layer will be 170 degrees Celsius. So there must be some region here. 一定呢個唔知邊個位置。It has a temperature of 174 degrees Celsius. It will condense somewhere here. So for this hydrocarbon C10H32, it can pass through the first two layers but stopped in front of the third layer. 佢穿過頭嗰兩層，但係穿唔過第三層。It will stay in this region. Okay, for the next hydrocarbon, this hydrocarbon, I'm not going to work it one by one, but you can work it by yourself. Before you work their relative position, I would like to have a very brief summary of what we have discussed here. First thing, this fracturing tower, because the furnace is located here, the region closer to the furnace will have a higher temperature. The region further away, the higher position, it will have a lower temperature. The second thing, because of the design of the bubble cap, there are different layers, separated layers in the fractionating tower. Third one, any vaporized hydrocarbons, it will flow into the tower. For those exist as gas form, it will go up. For those it is not being vaporized, if it still exists as liquid, it will flow downwards. Number 4, any hydrocarbons, it cannot pass through the layer with the temperature lower than its boiling point. Or this is a very important rule, number 4. So now I put the case again. Imagine I have these 10 hydrocarbons. I put it inside a fractionating tower. I heat them up at 400 degrees Celsius. So where can I find these hydrocarbon in different regions of the fractionating tower? You can pause the video and think about the new position of them, and you can continue. Now, I'm going to move on. OK， 未做嘅 pause 入邊先做 ，pause 咗入邊做完先至再睇。好啦，我而家嚟咯。頭先講咗嘅 ，this one is still exists as liquid, flow downwards. Next to it is being trapped between these two layers. Next one is trapped here, and then the next one, CH18 trapped here because it has a boiling point of 126 degrees Celsius， 穿唔過120度呢一層，但係穿得過170度呢層，所以佢會喺呢度。如此類推 ，here, here, and here. Okay, can you see what are we actually doing? Boom! What are we actually doing? You are separating the hydrocarbons according to different boiling point range. Can you see? Those with boiling point above 350 degrees Celsius, they can't pass through this layer, flow downwards, or being trapped in this region. For those boiling point between 250, the temperature of this layer and 350, this layer, they're trapped in this region. Boiling point between 170 and 250, they trap in this region, and so on, so on, so on, and so on. We are separating them into different parts. We are separating the hydrocarbons into different simple parts. Simply a mixture with a specific boiling point range. How can we call these parts? 就係頭一兩條片同你講嘅 ，they are actually called fractions. Different fraction, different parts of the crude oil. Each part they are simply a mixture with specific boiling point range. This is the method for us to separate the crude oil, to refine crude oil in a large scale. 工業上我哋就咁樣做啦。Actually, for each fraction collected in the fractioning tower, they have a specific name. So, I want you to have a textbook ready at page 80. So, I briefly introduce what are the identities of these oil fractions. Now, this picture I just copied from the internet from Google search. Now, I'm going to refer to a textbook. Okay, for the oil fraction below 40 degrees Celsius is collected in the top part of the fractioning tower. They are actually liquefied petroleum gas. 第一隻 fraction 就係石油氣 liquefied petroleum gas。冇錯，石油同石油氣而家嘅分別就喺度。Liquefied petroleum gas is a fraction of crude oil。石油氣係石油嘅一個 fraction 嘅一部分嚟嘅。呢個咩改得靚 ？Petroleum gas, they are the gaseous hydrocarbons. They have very low boiling point. That's why they exist as gas. Usually, when we use it, we will compress it， 會壓縮咗呢啲石油氣，所以英文叫做液化石油氣 （liquefied petroleum gas） in short form LPG. So the use of LPG usually in two different areas. In some region, maybe some outlying islands, they will use these liquefied petroleum gas cans， 有石油氣罐咁樣去煤氣公司訂翻嚟一罐，擺喺屋企廚房樓下，攞嚟煮嘢食嘅。Nowadays, the taxis they are using liquefied petroleum gas as they are better fuel. They produce less air pollutants. Now, how about next one? 第二隻出嚟嘅 the boiling point range 40 to 70 degrees Celsius. They are called petrol 汽油或者叫做 gasoline. These two names are also acceptable. 嗱，我字正開完多次，係 petrol 唔係 petrol， 唔係巡邏嘅 petrol， 係好似寵物 pet 嘅 petrol。咁如果你屋企有人揸車的話， 咁揸私家車油站入油排一條隊，就係入汽油嘅 petrol。Next one 70 to 170 degrees Celsius， the boiling point range in between. This is called naphtha。好，呢度我要轉一轉筆先。請大家同我留意一樣嘢，考試時候極多人串漏咗呢個 H， 因為唔發音嘅呢個 H。naphtha 呢個中文叫石佬油。Usually it used to make two things。我呢個 PowerPoint 冇嘅，但係你本書有嘅。Usually is used to make tan gas or and very important material plastics。遲啲我會再講。Next one kerosene。我係 kerosene，都唔好串錯，一圖會唔少手多。以前考試會寫咗 CE 咁樣嘅 kerosene or kerosenes。Boiling point in this range， 通常俗稱叫咩咧？火水。咁其實嚴格嚟講，呢隻學名叫煤油。咁以前香港你阿爺阿嫲阿公阿婆嘅年代，可能會用個火水爐嘅煮食爐，倒啲火水落去嚟煮嘅。Nowadays, kerosene is commonly used as fuel for the aeroplanes. Next one, diesel oil. The boiling point range here. Usually, they are used to power up some heavy vehicles, such as lorries, bus, 嗰啲嘅 coach 嗰啲旅遊巴咁樣嘅。Now, although this diesel oil it is more air polluting.It may produce larger amount of black smoke, but they can store a larger amount of chemical energy inside。佢儲能量多啲嘅，可以支持到呢重型車可以行長少少。如果你學校旅行個旅遊巴用汽油嘅話，可能行完屯門公路已經冇油㗎啦。呢隻嘢，如果你屋企人揸貨車嘅，有啲個別型號嘅 van 仔入油站排隊，可能佢會入呢個入油渣或者入一個叫柴油 diesel oil。OK，next one， 呢度咧唔同書有唔同嘅寫法嘅，唔視乎嗰個 fractionating tower 嗰個 design。For higher boiling point range, some of them can be used as fuel oil. Usually they are powered up for large ships here。咁呢隻可能係麗星郵輪、雙魚星號或者鑽石公主號就會用呢一隻咁嘅 fuel oil。Wax 中秋節或者有人生嘅時候嘅呢啲蠟燭，其實 they are hydrocarbons of very high boiling point solid. For those with even higher boiling point, they are called bitumen。通常係做咩咧？呢啲馬路鋪路嗰啲，你可能知道咩嚟㗎？咁就俗名叫做瀝青。OK， 呢一隻瀝青 for road covering。Now these oil fractions, the common use 兩大類。First one, domestic fuel that may use as the fuels for cooking or the fuels for transportation。呢啲頭先講咗啦。Next one, some of the crude oil fraction they are the raw materials for making other chemicals。點解我哋無啦啦學 crude oil 嘅？點解學下 metal 嘅 crude oil 嘅 ？Actually, we come to the beginning of another story。我同你睇過 new materials， 所以講過我哋著咗 plastic age。其實 oil fraction 頭先講嘅石佬油就係我嚟整 plastic products。They are used to make plastic products. Some of the plastic is commonly used as clothing。你件衫個 label 可能見到嘅，特登拍呢個 video 就着第二隻衫嘅 polyester 聚酯 polyester。Some of them may use to make other chemicals, paints, Form 5, Form 6 organic chemistry 讀嘅 detergent, ointments 同埋嗰啲 hand cream 等等。They come from the crude oil。仲有一啲嘅 candles, pesticides 等等等等。Alright, so I want to take out a textbook and go to page 78 for some underline here。好，我轉一轉畫面先。Okay, for page 78, I want you to underline these parts。咁頭先講嗰啲 fractional distillation 咁複雜，考試點寫啊？呢啲就係我要你識嘅嘢啦，我 Form 3 level 要你識嘅嘢。So oil refinery is actually the summary for today's video, for the content of this video. first heated to about 400 degrees Celsius in a furnace. So hot crude oil, it will turn into partly liquid and partly vapor. The liquid part flows to the bottom, and the vapor part rises up the tower. 好，咁如果我問你 the principle of fractional distillation, don't say the hydrocarbons condense at different level. Please state the trend. The fractionating tower, the lower levels are hotter than the higher levels. So the hydrocarbons, they could condense different level. 個 trend 係咩啊 ？Larger molecules, they have higher boiling point. They condense at a lower hotter level. Smaller molecules, they have lower boiling point, condense at higher cooler level. 得唔得 ？So in general, here condensed hydrocarbon can be collected as different fractions. So page 79, okay, page 79. This part they will have different flow here, or different flow here. 自己睇得唔得？自己睇。好，下面個 part 寫翻個字啫 ，fractional distillation. This one is very simple. Okay, and then for the uses of oil fraction, page 80. 好嗱，睇到最後通常有彩蛋嘅，呢、個彩蛋好重要，我而家話俾你知嘅。考試嘅時候你要記啲咩咧 ？You just need to memorize the trend here. 我會問你個次序。However, no need to memorize the boiling point range. 我自己都記唔到嘅，我都會唔記得嘅。同埋 different design of the fraction tower, they have different boiling point range at different level. I will not ask you about the exact temperature here, but I will ask you the order 由 LPG 去到bitumen 得唔得 ？OK， 去到呢 part。So we finish the part for fractional distillation. So please, for page 82, I want you to complete page 82 about the quick practice and also page 83 about the quick practice. 有啲考試嗰陣已經做咗㗎啦，得唔得 ？Okay, so for this video is a little bit long. I will stop here.